Now, without further ado, we welcome our partner presentations all about satellite and cloud foundations. Please welcome to the AiDASH Evolve stage, Sean Veet from Up 42.
Good morning, everyone. It's a real pleasure to be here at the Evolve conference. We're very happy the sponsor as well. We sponsor quite a few events in the geospatial industry, and usually I speak to my marketing team afterwards and did we really need to sponsor that one? Did we really get our money's worth? And I'm very happy that Abhishek and the team have put on such a good show for us. I think we've got our money's worth definitely this time around, so thank you for that. I don't normally sound like this. I think, like many of you, I lost my voice somewhere in Bourbon Street last night, so if any of you found it, please return it to me after the session. So what I'd like to talk to you about today is a little bit about what happens behind the scenes, right? So Up 42 has been working with AiDASH since 2019, helping them to bring satellite imagery and other kinds of geospatial data into their solutions in order to help you as their customers. And I'd like to talk a little bit about some of the complexities there and what we're doing to help. So I have spent around 25 years now focusing on geospatial data, geospatial solutions, geospatial platforms. And what's kept me in the space for so long is the profound impact that geospatial data of all different kinds, not only satellite imagery, but also aerial imagery and other kinds of data, can have on almost every single industry that you can think of. Of course, we've heard a lot about vegetation management and utilities in the last 2 days, but you take the same scale of problems that you guys are experiencing in your industries, and you can translate it into anything you like, whether it's on emergency services or healthcare or supply chain logistics or whatever the case may be. And this applicability of this technology to so many aspects of life on Earth is really what keeps it interesting and motivating for us. And I think particularly what we're seeing now around satellite imagery is even more profound. If you think about the impacts of our entire geopolitical, environmental impacts, our economic impacts that we have across the globe, anything that we're doing is having a global effect nowadays, and I think that space is probably one of the only vantage points that we have left where we can all keep each other honest and really see what's going on. I think this is a very powerful idea. And I think that vegetation management using satellites is one of these examples where we can start looking towards profound impacts on the efficiency, on economies of, on the economy, on social impacts, and also making sure that you can keep people alive, as we heard yesterday through all of these disasters. So what is Up 42? Up 42 is a company that was formed in 2019. We are a startup of around 100 people based primarily in Berlin, in Germany. And we have built a geospatial platform and a marketplace with the goal of making sure that it is easier for people to get access to geospatial data and to build solutions with that geospatial data. We've focused primarily on building a collection of data providers all under one roof, a collection of algorithm and analytics providers all under one roof, but more importantly, making sure that all of this technology is available via API and that it can be automated and that it can be scalable, because otherwise, as we heard from Josh from Maxar yesterday, there's no ways that you're able to look at all of the data that's collected. You need to be able to order it automatically. You need to be able to process it automatically as well. So we are razor sharply focused on this problem in the industry, connecting all of the amazing things that are happening in the space industry and with operators like Maxar and others upstream to the downstream applications and the people who really understand the industry and are building the solutions to solve those problems. So we saw some slides like this yesterday, so I'm not going to go over in too much detail, but one of the reasons why we have a profound proliferation of capabilities in space right now is because of the changes that we have in the industry from a technology perspective. So we've had a decrease in satellite size in many cases. We have a decrease in production costs. We have a significant decrease in cost of access to space and the number of launches that are going up there. And that basically has meant that there's a lot more companies that are putting satellites into space. And then on top of that, there's a massive increase in the ability to get data from space down to the ground, store it in the cloud, process it in the cloud, And again, on top of that, we have all of the advances in machine learning and AI, which is helping us to process this data at scale. These are obviously all of the technology push factors. Of course, on top of that, we have all the pull factors that you're all aware of in terms of legislation, real-world problems that we have related to climate change, et cetera. But basically, what this leads to is a proliferation of options that you have, and the variety of what you're able to get access to from space is starting to increase dramatically. So it's not only about an increase in resolution, it's about an increase also in the revisit rates, how often you can get data over a particular area. The depths of the historical archives are increasing very rapidly as well, so you start to get a much richer access to data for looking at things happening over time. The ability to turn around capture and tasking of satellites for specific use cases or for your specific projects, that's increasing as well. We are often, for example, doing before and after tasking using radar satellites along railway lines to make sure that we can see the impact before and after storms. So it's really starting to be something that can get you real situational awareness on the ground very, very quickly. And then, of course, we have the variety of image types as well. So it's not only optical, but radar, lots of different bands coming in, different spectral resolutions, as again, Josh was explaining yesterday. Thermal, multispectral, hyperspectral, and this basically just starts exploding the number of use cases and the possibilities of the questions that you can actually answer using this data. And this is leading to an explosion of downstream applications. And for me, what's exciting is that everyone in the satellite imagery industry has always known that these applications are possible, technically, with the data that's there. But quite often it's been not feasible from either a financial perspective or from a revisit perspective. There's been some things that have been holding back the adoption of satellite imagery for solving some of these use cases. And we start to see these barriers falling away and making these applications way more feasible than they were previously. We are serving around 350 customers globally, thousands of users across almost every single industry that you can imagine, from linear infrastructure management, construction monitoring, construction planning, food security in Africa, flood mapping, et cetera. It's incredible what you can do with this stuff. However, it's also problematic. It's very difficult for companies that would like to work with multiple data providers to actually get that to work, because the industry is extremely fragmented. It's commercially difficult, it's technically difficult, and that's where we come in as a platform to try and consolidate all of that. So just a quick word on how we do that for AiDASH, right? As I mentioned, we've been working together with them since 2019. And AiDASH came to us with the same problem that they have this, would like to work with satellite imagery, and came against a number of challenges that many of our customers have, and which is that trying to close contracts with a lot of the satellite imagery providers, trying to deal with multiple APIs, different ordering types, different data formats, all of these different things, very, very complicated. And this essentially increases the underlying costs that you have as a company that's trying to work with satellite imagery and build solutions, because there's so much heavy lifting that needs to be done first before you can even start working with the data. And that's where we come in. We have a one-stop shop, which bringing lots of different data collections under one roof. We have 86 different partners on our platform already, and that is growing all the time. We have a scalable API-based platform where essentially a lot of the ordering and data delivery is automated. It has to be. We have customers sometimes placing 15,000 orders a day. You cannot do that by using a user interface. It has to be automated. We also provide a trusted advisor and customer support function to help AiDASH and our other customers to know what kinds of data are best suited for their use cases from a technical perspective, collection time frame perspective, and from also a cost feasibility perspective. So we play this neutral, trusted advisor role in the industry as well. And you put all of these things together, and what that means is that Up42 has become a scalable and reliable data pipeline for AiDASH to power their UVM solutions and to help you to solve your problems on the ground. So just a quick word on what our platform looks like and how it works. No major demo or screenshots or anything. We're just sort of going through the major parts of it, right? So on the one side, we have our data services. This consists of two pieces. One is the catalog, where essentially in one user interface or one set of APIs, you can browse through the catalogs of multiple providers and filter for things like, what kind of resolution are you looking for? Are you looking for optical data? Do you need an infrared band? And essentially be able to look through and see if there's data already that suits your needs. and basically order that data into your account on the platform. And then as well, we have a UI where you can task satellites, and basically, again, using the same flow, the same APIs, the same user interface, you can task satellites from multiple providers. I think we support tasking for around 25 different providers at the moment. And again, in the same flow, in the same user interface, and it makes it very, very easy for you to bring data into your projects. Once the data's come into the platform, doesn't really matter if it's from archive or from tasking, it goes into our data management part of the platform. The previous speaker basically mentioned that wouldn't it be great if we could have a place where all of this data is brought into one spot for the enterprise, and that all of your users can already see what we've bought already before going and buying more data, right? And that's exactly what this piece is. We bring in consistent metadata, so all of the data is searchable using the same mechanisms. We've basically converting all of that data into the same data format, so it's immediately usable in your GIS applications. You can even stream it directly into ArcGIS, QGIS, et cetera, using all the streaming functionality directly from the platform. Then we have our processing pipelines, where you can enhance the data, run object detectors, all those kinds of things on top of that. There's a few things there on account management and compliance, et cetera. We won't get into that now, but of course, for satellite imagery, it's extremely important to be robust on the compliance side. We are talking about dual-use technology here, and of course, we need to keep it safe and make sure we're not giving it to the wrong people. An important part here is that we have different ways of accessing the platform. Yes, you can use it via the user interface, but 90% of our customers, or 90% of the usage of the platform, is flowing via the API or the Python SDK, because that's what geospatial people like to do. And on top of that, we have a very extensive documentation hub, developer support, code samples, open source examples, et cetera, and again, our customer success team, which is there to help you for every step of the way. In terms of data, we have optical data from satellites. We have optical data from aerial imagery providers. We have SAR imagery. We have elevation data, drone data, and thermal imagery as well. We're aggregating providers like Airbus, Vexel, Planet, Capella, ICEYE, Umbra, Synspective, and many, many others. As I mentioned already, we have more than 85 different partners. On the processing algorithm side, there's quite a few algorithms there to help you to pan, sharpen, prepare the imagery, co-register it, make sure that it's analytics ready. And then on top of that, we have a bunch of algorithms in place where you can, across different providers, run object detectors, extract buildings, all these kinds of things. And that just helps us to get up to speed as quickly as possible. Key takeaways for utilities, I think this is a key thing for what I want to leave you with, is satellite-based UVM is growing really fast. We're supporting AiDASH and a lot of other companies in the space, and we see that the ability for satellite imagery to impact this industry is really profound, and we're very excited about where it's going to go. I think it's only scratching the surface, and we're going to get to the point where it's going to be, I think, by far the predominant way of vegetation management in the future. Certainly, it's the fastest growing commercial use case of satellite imagery that we see today. Access to multiple data sources is key. There's different questions, different kinds of sensors. You need to know what you're trying to do, and you need to be able to have the redundancy and the resilience in your pipelines to go across different data providers as well. Analytics capabilities expanding rapidly. I think AiDASH has covered that very, very well in the last day in terms of their different capabilities and how they're expanding the possibilities based on that data. And I think it's really key also, and I think we heard this multiple times, that it's not a silver bullet. There's still going to be other data sets required, whether it's weather data, LiDAR, drone data, et cetera, to complement satellite imagery. And with that, I would like to end it. If you'd like to come talk to myself or my colleague John in the demo lounge afterwards, very happy to show you around the platform, talk about what we have. And again, what's important for us is that we rely on the data providers, the amazing satellites that they're putting in place, and also the strong data pipeline capabilities that they have, and looking forward to Bryan from Maxar talking a little bit more about how Maxar is doing that as well in just a second. Thank you very much.
Thank you, Sean. Next up, we have Bryan Smith, Director of Product Management from Maxar. Welcome, Bryan.
Hi, everyone. I'm Bryan Smith. I'm the Director of Product Management leading our 2D products, so our imagery and our base maps, and also our platform products. Today, I wanted to give you a little bit of a glimpse behind the curtain, go into a little bit more detail about how we collect imagery, how we also then disseminate imagery and make it easy for our customers to access. But before I dig in, I first want to say thank you to the AiDASH team. It's been an absolutely wonderful event. I wasn't expecting gospel singers. I wasn't expecting them closing down, Canal Street. It's really been just wonderful, and that's not even getting into the conversations we've had. So my hope is that I can add a little bit more to this event, leave you with just a little bit of insight behind the curtain on what we're doing to support our wonderful partner. So with that, I want to start by talking a little bit more about our constellation. My colleague Josh yesterday started to talk about our satellites. And if you recall, he talked about how we started the year with 4 satellites. We've added an additional 4, and we have 2 more on the way. So those 6 satellites that we've added this year, 4 that we've added, 2 that we have coming, in our eyes are really a transformative capability. To date, we've been capacity constrained. We haven't had enough capacity over the areas that matter for our customers, that matter for you all. It's limited AiDASH's ability to serve you. And this, in our eyes, is transformative. It's transformative because suddenly you have the data that you need to provide those robust analytics. And so with that constellation, we're extending our resolution, so 30-centimeter resolution. As Josh mentioned, 30-centimeter resolution means each pixel is about a foot. So you have really a crisp view on the ground, which translates then into better analytics. We have high accuracy in our satellites. So it's not just having a clear view, but you need to know where you're looking. And we also blend that into our capabilities. We have spectral bands on those satellites where you can certainly determine if vegetation is healthy, might be indicative of fire risk or other issues. And with Legion, if you remember from Josh's presentation yesterday, traditionally our satellites have orbited like this, so they image at the same time every day. We're moving to having many of them orbit like this, which gives us multiple accesses throughout the day. You can image a specific location up to 15 times. Now, granted, are any of our customers really going to do that? Probably not. But what that means is you have more opportunities to image, more opportunities to look around clouds, more opportunities, again, to get those clear pixels that matter so you can get the analytics you need, to better manage your business. Last point I think here is key. It's just a lot more capacity, a lot more ability for us to better serve you, to better serve our customers. So next what I want to do is I want to go into a little bit more detail on the actual satellites themselves. And then what I'm going to do is close by giving you insights into how we're delivering that data, how we're bringing it to the cloud, how we're making it easy for our customers to access our content. So first, just more on the fun side of things. I think satellites are fun. Maybe I'm a satellite nerd. I am a satellite nerd. But the satellites are about 2 meters wide, 3 meters tall. They're about 1,400 pounds. So what we have essentially is it's like a hatchback car. It's like a Mini Cooper. Previously, our satellites were like a small school bus. So we've moved to this smaller form factor. It makes us be able to launch more of them up there into space. When we launch them, right now we're going on a Falcon 9 rocket, so the SpaceX ones that you've likely seen. These rockets launch us up to 320 approximate miles above the Earth's surface. I actually had the pleasure of going to a launch event with SpaceX. It was over at Vandenberg Air Force Base. Nice event, failed in comparison to the AiDASH event. There were no gospel singers or anything else. But it took us to the vineyard. They drove us in a nice bus to the launch pad. We were all very excited for the launch up until we saw the 6-story rocket not pointed up, but pointed sideways. And there was a problem, it got scrubbed, but they eventually got it up there. I'll see a launch one of these days, hopefully. When they're up there, they orbit the Earth at 17,000 miles per hour. And along their orbit, the whole way, we're slewing left, we're slewing right, and we're taking images. So we're not a constellation that just looks straight down below. We're able to move around clouds. We're able to image in different ways to get the content that our customers need. And despite the height, despite the speed, we're able to get images at 30-centimeter resolution. So again, each pixel being about a foot, square foot. What we have here, I think we showed yesterday, I should have coordinated with Josh better on my slides next time, is another rocket launch. This was a ULA launch. But what I think is key and kind of cool and illustrative about this example is you can read the lettering of ULA very clearly. You can see the difference between a sedan and a van and a truck. You can see just that much more. And if you can see it, you can also extract more information via AI ML as a result of that. And you can do it with much more clarity. This example, again, showed it yesterday. What our customers use this for is actually being able to trade. So they're looking at global oil supply, they're looking at where these rooftops are, and as a result of that, they're being able to abstract out and inform their commodity trading strategies, get an advantage. And they trust it. They trust us for this kind of information because of the quality of our data. This is another example on the maritime side of things. What I'm not showing here is frankly what a lot of our maritime customers use us for, which is defense and intelligence purposes. Where are their submarines at berths? Where is the foreign maritime militias incurring on foreign waters? We serve over 400,000 US government users on a daily basis. We've got over 50 international defense and intelligence companies that trust us. We are their trusted mission partner for insights. And it's because of the resolution. It's because of the quality of the data. It's because we deliver. But beyond the resolution, we're also highly accurate, which matters if you think about an analytic. What we're displaying here are 3 circles. The outermost circle in turquoise is representing 100-meter, what we call CE90 accuracy, meaning the point in the middle that the satellite is intending to image 90% of the time will be within 100 meters. The same then for that blue circle, except for 20 meters. So 90% of the time it's within 20 meters. And the last one is orange, which is 5 meters. And that's where our accuracy lands. When we point our satellites, 90% of the time we are within 5 meters. And what you'll see from other players in the industry is those outer bands or the middle band. And this is just yet another example of why our high quality data, or a representation of our high quality data versus others. And then if you think about an analytics use case, if you're trying to do change over time, if you're trying to understand where vegetation might have changed, you need that level of accuracy. It's hard to automate any of these workflows if your data is moving around all the time. Beyond just the individual attributes of our collection, we're also collecting at scale. This is the 6 months of collection with our existing constellation today. With Legion, we're even adding on top of that. So we're going to have approximately a 3.5 increase in our 30-centimeter capacity. That's about equivalent to 6 times the area of the United States. That's not saying we're imaging the United States 6 times, but globally, that's the area. We have an almost 2x increase in our color capacity as well. So again, it's not just the individual images, it's not just the accuracy, it's not the resolution, but it's also the scale that we're able to do that going forward, and what that means for AiDASH and for you all. Whoops, is that displaying right? Nope. Beyond just the satellites though, it's also the ability to access the data through our Maxar geospatial platform. So our Maxar geospatial platform allows it for our customers easy access to all of our imagery content, our 3D content, our analytics, things like change monitoring, things like object detection. It allows our customers to task our satellites. We have API access to this content, so programmatically you can task, you can download content. We have UI access, and it's all accessible within a seamless consumption-based business model. Wish that slide had displayed though. It would have made this a little bit better, but hopefully you get the point. So we're not just doing everything up in space, we're also taking that data down, pulling it into the cloud, and making it easy for our customers to integrate it into their workflows. And lastly, what I have is an example of what that looks like via our UI, where you get all of that resolution from satellites that are orbiting the Earth at 17,000 miles per hour, yet able to collect an image at 30-centimeter resolution. You have the high accuracy, and you have all of that content available within an easy-to-access platform. I want to close by just saying again, thank you to AiDASH. And from my perspective, I'm incredibly excited to see what the AiDASH team can do with this new capability, with the new capacity we have coming online. So thank you all.
Thank you so much, Bryan. Now, we finish strong with our final partner presentation from Marco Masciola from Amazon Web Services. Welcome, Marco.
Hello, can everyone hear me okay? Excellent. So I'm here today to share Amazon Web Services' point of view on why technology-driven vegetation management solutions is an important step to securing and protecting critical energy infrastructure for our communities. And my name is Marco Masciola, and I am a partner solutions architect at Amazon Web Services. And part of my role at AWS is to support AWS partners in building solutions of the future on the cloud. And one of my areas of work is within sustainability. So I support partners on energy transition, energy transformation, ESG reporting, sustainability regulations, climate and nature-based solutions, and the type of solution that AiDASH has is dear to my heart. And as we learned over the last 2 days, vegetation management is a complex issue to solve at scale, and technology does play a role in helping to break down this complexity for customers. And what I want to share in this short talk is how AWS supports AiDASH in this mission. So to put a few data points on a board, and there's similar data here that Sachin shared in a few slides, a few presentations ago, is that to meet energy transition goals in the future, approximately 50% of the energy that we consume would have to come from electricity. That number today is 21%. So there's a lot of ground to cover to meet climate goals in the future. Researchers have also shown that over the last decade, outages have increased by 64%. And the single largest source of these outages is tree collisions with power lines. And as a result of this, the power utility sector has invested into vegetation management solutions. And they currently invest about $7 billion to address this singular issue. So if we put this all together, what we realize is that vegetation management is a costly problem today, and it's going to be even more costly in the future. So this is where for the reasons outlined in the previous slide, this is why AWS views the partnership with AiDASH as an important step to help meet energy transition and climate goals in the future. And AiDASH is a validated AWS partner. And what that means is that there's two areas that AiDASH excels in. The first one is that they bring industry domain expertise in solving a customer use case challenge and an industry use case challenge. The other area is that they demonstrate cloud technical expertise to solve the industry challenge. I do want to double click on what cloud expertise represents, because this is a unique element to what we heard over the last few days. So by cloud expertise, what this means is that AiDASH is designed with security best practices. So this means that do they meet industry security compliance standards? Do they have certificates that demonstrate that they meet these specific regulatory requirements of heavily regulated industry like power and utilities? The other element to this is data governance. We just heard this in the previous presentation, and what data governance represents. Is data protected and secure? Or could data be audited? Do we know who has access to what data? When did they access it? These are elements that AiDASH demonstrates as part of being a validated partner. The other element to it is reliability and availability. Is the solution designed to always be available for customers when they need it most? And then there's a fourth element to this is performance. Is the solution and the offering designed to be performant to meet customer expectations when they need it most? So these are all elements that AiDASH demonstrates as a validated partner that in wearing this validated partner badge, that they are demonstrating that their solution meets cloud design best practices that are designed by industry. So to peel away on the partnership level one level further, I wanted to explore how AiDASH and AWS are complementary to one another. So AiDASH provides, they combine geospatial data with LiDAR data and artificial intelligence to achieve 90% accuracy in calculating highest risk areas for at-risk circuits and power lines. This AI model is also based on, is trained on 10 years worth of data. But when we look at it from the perspective of there's a lot of data, a lot of geospatial insights, AI models, this workload has to run somewhere. So this is where the AWS component comes into play. So what AWS is we are a IT infrastructure and technology provider to organizations like AiDASH, where they could run compute workloads on a data center somewhere. So we heard the term data center a few times between yesterday and today, and you could think of AWS as the physical hardware where servers are located, where customers could host their data, where AI workloads could run in a remote environment. The other element that AWS provides is that we also have over 200 services that could be used to accelerate the design and implementation of new IT workloads. And one example of this is the 23 artificial intelligence and machine learning services that AWS has that could be leveraged to develop new AI models. So you can think of this as your Lego blocks that start the foundation of a new technology that you could build on and fine-tune the model to meet a specific expectation for a workload that you're trying to design. The last element is that AWS also has 200 data centers globally dispersed across the globe. What this means for customers is that their workload and data is stored close to where they are located. This reduces latency and access to data sets. Overall, this improves the customer experience and bringing the workload to where they're situated so that it improves reliability, performance efficiency, and accessibility to resources on a cloud. Now, if we look into the future, both AiDASH and AWS see an expanding energy sector. The data supports this, and we see that technology plays a role to solve complex cross-domain energy sector challenges. This path will be evolving, and there are some experiments for us to try out new things, test out what works best for customers, and this is where AWS and AiDASH, this is the field that we play in, is how can we leverage the latest compute resources on AWS to solve a specific customer challenge. The other element to it is conferences like this is I view it as an opportunity to hear directly from customers, what they would like to see, how we could adapt the current solution, working with AiDASH directly with the customer on how could we improve where we're at today and solve a future use case. So we may be looking at the step in front of us, but what's the next challenge after we tackle step number one? What's step number two? So I see conferences like this as an opportunity to, foster dialogue on what is the next big challenge that you'd like to overcome. And this path will be evolving and adapting according to customer needs. And the key to this partnership with AiDASH is that we are leveraging IT together to solve a customer use cases. And as part of innovating and moving fast, AiDASH and AWS are also working together on how we could leverage the latest cloud services to solve customer workload challenges. On this screen, I'm only showing 3 AWS services. These may be familiar to some of the folks who dabble with AWS, but AWS has 200 other services beyond what's on this screen. What that means is that this allows us, we have the resources or the tools in the toolbox to help customers solve virtually any workload challenge. So with that in mind, we work with AiDASH on figuring out what is the best compute resource to solve an artificial intelligence or machine learning workload challenge. And this could constitute, we need to train a new model, or we need to deploy a new model. They're 2 different use cases, and we have specialized services to solve each of those domain challenges. The other element is storage, Amazon RDS. That's a SQL database. But we could also explore how we could integrate new storage patterns into existing artificial intelligence and machine learning models to deploy new insights and new information faster to the field. So this is another area where we continuously innovate as new technology barriers are broken in a space of cloud computing. The last element is Amazon SageMaker, which is AWS's flagship product for building custom machine learning and artificial intelligence models. The benefit of this is that it provides a playing field where it's easy to experiment with new models and integrate petabytes of data into an easy-to-use platform to just test out and try out, well, how does this new innovative machine learning model that I have in my mind, how does it perform? SageMaker is the playground to test that out. And it goes one step further that SageMaker is also an easy entry point to integrate a new model in a test environment into a production workload. So this in a nutshell is sharing some of the areas where AiDASH and AWS are working together. And AWS is behind the scenes, AiDASH builds the product. We ultimately support AiDASH and the customers to address real-world use case challenges. So with that, I just wanted to end that vegetation management is complex, and I think after this conference, I appreciate even more the complexity in it, the stakeholders that are involved in it, the hazards that are involved. But you know, AWS is trying to do our part to support AiDASH on unconstraining this challenge. So thank you, everyone, and thank you to AiDASH for hosting an amazing conference.